In this video, we will solve a numerical on profit maximization and checking the second order condition also. The question is, the profit maximizing output for the revenue function R is equal to 1000 Q minus 2Q square, where Q denotes the output, R is the total revenue, and cost function is being given as C is equal to Q cube minus 59Q square plus 1315Q plus 2000. Options are being given. We need to find out the profit maximizing output here, okay? So basically, what we are being given a total revenue function, that is R is equal to 1000 Q minus 2Q square, and also we are being given the cost function, that is total cost is being equal to Q cube minus 59 Q square plus 1315 Q plus 2000. Okay, now profit maximization condition, as we know, and let me write it here. Profit maximization will require that we equate the marginal revenue with the marginal cost. Okay, simple thing. So this is total revenue function. To find the marginal revenue, so we know marginal revenue is simply the derivative of revenue function with respect to output. Okay, taking derivative of this function with respect to Q, derivative of Q is 1, so we are left with 1000 minus derivative of Q square is 2Q, so 2 into 2 is 4Q. Okay, symmetrically, to find the marginal cost, we take the different the derivative of this total cost function with respect to output. That means, and let me be specific here, our marginal cost will be the derivative of cost function with respect to output. Okay, so derivative of Q cube is 3Q square minus derivative of Q square is twice Q, so 2 into 59, we have 2 into 59, so this is 2 nines are 18, 2 fives are 10, this comes out to be 2 nines are 18, 2 fives are 10, and we get 1100, sorry, 118 Q here. So let me write it here. So 118 Q, derivative of Q here will be 1, so we will be left with 1315 only, and derivative of a constant is 0, obviously. Okay, now profit maximization, as we know, profit maximization will require that we equate marginal revenue with marginal cost. Okay, so this is our marginal revenue, 1000 minus 4Q, 1000 minus 4Q, and we equate it with the marginal cost of this stuff, that is 3Q square minus 118Q plus 1315. Okay, let's draw the graph also to make it more meaningful. So we have quantity on the horizontal axis, price on the vertical axis. Okay, I will not draw the demand function here, rather I will draw the marginal revenue function. So we have this marginal revenue function is, its intercept is 1000. Let us say this is our marginal revenue function. Okay, marginal revenue function. Also we have the marginal cost function. This is a quadratic one, and its intercept is 1315. Our marginal cost function will look like this, and it will look like this. Okay, this is our marginal cost function. As we know, marginal revenue equates with marginal cost for profit maximization. Okay, so we solve this function here for Q. So let's write it here. So we have 3Q square, transposing this, rather let me write first this 118Q, transposing this, it will become plus 4Q, then we have plus 1315, and transposing it will get subtracted, and we set it equal to 0, so we get 3Q square minus 118 plus 4 comes out to be 114 q, plus subtracting 1000 from this 1315, we will get 315, and we set it equal to 0. Here all the terms, be it the constant term or the coefficient of q or the q square, they are divisible by 3. That means we divide both sides by 3, so we will get q square minus, here 3 3s are 9, now that 3 3s are 9, 3 8s are 24, then we have q plus, here 3 1s are 3, okay, 3 1s are 3, then 3 zeros are 0, and 3 5s are 15, and we set it equal to 0. Now using quadratic formula, so we can write q will be equal to, we know in the quadratic formula, this minus 38 is our b, this is c, and a is the coefficient of q square. Okay, so quadratic formula is simply minus b plus minus b square minus 4ac divided by twice a. Okay, so in place of b we have minus, so we have minus 38. Okay, minus from the formula, and b is minus 38. Then we have plus minus b square means minus 38 square. Then we have minus, then we have 4ac. 4 from the formula, the coefficient of a is 1 and c is equal to 105, and we divide it by twice a, 2 times the coefficient of q square. So that implies q will be equal to, that is, we have 38 minus into minus is plus, 38 plus minus, now 38 square, square of a negative number is always positive, so we have 38 into 38. Okay, I have calculated this 38 into 38, it came out to be, I don't have the calculator here, right? So it comes out to be 1444 minus 4 into 105, it comes out to be 420 divided by twice a. 2 into 1 is 1, so q will be equal to 38 plus minus, subtracting 420 from this stuff, we will get 1024 divided by 2. That gives us q will be equal to 38 plus minus, under root of 1024 comes out to be 32 divided by 2. So here you can see we got two values for q, that is q is equal to 38 plus 32 divided by 2, which comes out to be 70 divided by 2, which is 35, or we get another value, that is q is equal to 38 minus 32 divided by 2, which comes out to be 6 divided by 2, which comes out to be 3. Okay, so here when q is equal to 3, this is q is equal to 3, and this point is q is equal to 35. We need to find out where will be the profit maximizer. That means we need to check the second order condition. Okay, so first order condition is, as we know, marginal revenue should be equal to marginal cost. This is the first order condition. Second order condition in this case is that the slope of marginal cost, okay, when it cuts the marginal revenue function, it should be positive. Okay, at a point of intersection between marginal revenue and marginal cost function, the slope of marginal cost should be positive. Okay, or in other words, marginal cost curve should cut the marginal revenue function from below. Okay, at that point the slope should be positive. So let us find out the slope at 2 pointers. Okay, so slope of marginal cost function, we need to find out, to check the second order condition, we need to check the slope of the marginal cost function at the intersection points, that is at q is equal to 3 and q is equal to 35. Now marginal cost function is somewhere. This is our marginal cost function. Now slope of marginal cost function is simply we take the derivative of marginal cost function with respect to output, okay, and we evaluate it at the critical points, or critical point is 3 and 50. Let's first evaluate it at 3 when q is equal to 3. So derivative, if I take the derivative of this cost function, rather this marginal cost function, so derivative of q square is 2q, so 2 into 3 is 6q, 6q minus derivative of q is 1, so we are left with 118, and derivative of a constant is obviously 0. Okay, now let's evaluate it at q is equal to 3. That implies 6 into 3 minus 118. 6 3s are 21 minus 118. 21 minus 118, it will come out to be negative. Okay, it is a negative number. Slope is negative here. Okay, it is negative because we have 21 minus 118. I'm not sure what will be, and let me see. 8 8 7 kahan is it now, so it comes out to be minus 797, which is less than which is negative. Okay, so slope of marginal cost when it intersects the marginal revenue function at this point is negative, so this cannot be profit maximizing output. Now what about when q is equal to 35? Again, we take the derivative of marginal cost function with respect to output and evaluate it at q is equal to 35 this time to see whether its slope is positive at that point or not. So simply, so this is our slope of marginal cost function, and we evaluate it at the critical point q is equal to 35. So we have 6 into 35 minus 118. It comes out to be at this point, so 6 into 35, it comes out to be 6 5s are 30, 6 3s are 18, arda kunu that is zahda minus 118, and here it comes out to be a positive number, and it is obviously the 210 minus 118. Okay, dahne orta z dahne orta z navanne acht, it comes out to be 82 if I am correct here, so it is positive. Okay, so we can say that when q is equal to 35, this denotes the profit maximizing output. Okay, so the correct option I guess should be C option, if I have done the calculation right here. Okay, so simple thing, first we need to find out the first order condition that tells us that we equate marginal revenue with marginal cost function. Okay, since we got two values for q, we need to check out the second order condition. Okay, we got q is equal to 3 and q is equal to 35. Now second order condition tells us that the slope of marginal cost function when it intersects the marginal revenue function, it should be positive. Here you can see it is negative, here the slope is negative, and at this point it is positive. Okay, on the rough it's okay, but to check it, we simply take the slope of the marginal cost function and evaluate it at the critical points. When we evaluate it at the critical points, we need to find out the output level where it is value comes out to be positive. So when q is equal to 3, we got a negative number. That cannot be our profit maximizing output, because it shows that the slope is negative this point. And again then we evaluate the slope of the marginal cost function at q is equal to 35, and at that point we got a positive number. That means this must be the critical point for profit maximization. I hope I make myself clear in this video. Thank you.